So everybody got their calculator out? Notice example A has the theta, which is an angle, and it says sine theta, so I know it's an angle because it's always sine of an angle. Notice that it's on top. That's good. That's what we wanted. That's what I said we wanted. So this is set up correctly. The angle's on top. We have to do one step to rearrange it. So to do that, we go sine theta equals, I multiply both sides by 41 to move it over. So I end up with, what's going on? So I end up with 41 sine 74 over 77. And when you punch this into your calculator, you're going to go shift sign. You don't have to write this down if you don't want to, but so you're going to get theta equals, shift sign gives you that sine -1 thing, right? Bracket, and you're going to put this whole thing in the brackets. So just watch for a minute. I'm going to do it here so you can watch. I can find my calculator. Okay. You see that? So I'm going to go shift sign bracket 41. Listen carefully. Sine 74. What a lot of people do here is they close the bracket. That's wrong. You got to put brackets around the whole thing, right? We're not just doing the top. So I divide by 77 first, then I close the bracket. So I've done shift side of the entire other side, and you should get 30.7865. It's an angle, so we round it to the nearest degree, no decimal places, so that would be 31 degrees. So see if you can get that on your calculator, 31. And if you can't, I will come around and help you in a moment. We're going to do 2, and then I'm going to let you try 2 on your own. If you have a one-step calculator like this, here's what you do. 41 times, remember you always have to put the angle in first, then hit sine. I'm going to hit equals. You probably don't have to. Divided by 77. Now you have to hit equals. And then at the very end, do shift sign, and you get the exact same answer. Okay, give that a try. Are some people getting it? Make sure you try it, because you got to be able to do this on your own. What do you notice about the second one?
Signs at the bottom.
Signs are at the bottom. And notice how both signs are at the bottom. And both signs are at the top. That has to be true. I hope you kind of got that. You got to be consistent. You can't flip those. That's not how the formula works. So both signs are on the bottom. Very good. And what's on top then? Lengths, side lengths, and x. So this one again is set up properly. If you start your homework, and when you sub in, you've got an x or a theta on the bottom. Like you started with the wrong formula, which is fine. I'll show you what to do. But you have to be aware, whoops, x isn't supposed to be on the bottom, it's supposed to be on top. So I got to do something to take care of that, right? You always have to remember. Okay, so I do x equals 13.1 times the sine of 50. So I took sine of 50 from the bottom on one side and multiplied on both sides, brings us to the top on the other side, over sine of 81. And this one's actually easier. It's just there's no shift sign, right? Because I'm not finding an angle. So it's just 13.1 sine 50 divided by sine 81. And we typically round side lengths to 2 decimal place, or to 1 decimal place, sorry. So 10.2. How many people got that one okay too? That one's the easier one. Some people might have been getting errors on the first one, but then we're getting the second one. Any questions so far? So I want you to try these two, and I'll come around and help you with your calculator problems while you're doing that. So who's having a hard time with the calculator? If your calculator opens brackets automatically, then you have to do it a little bit differently. Okay, so go ahead and take it. Yeah, 77. And then close that bracket, because that's just for the sine. Divide by. Everybody else okay? Which one? So that one's just 155, just the way it was, times. And how do you do this sine? What is the sine of 13? How do you do that? 13 sine. Yeah, 13 sine. Divided by 67 sine. What about the other one? The other one. So let's see if we can do it. So you don't do the shift sign first. 41 times now. To do that. Okay, show me how you do it. You probably have to go 41 times. 41 times. Oh, no, sorry. 41 times. You have to put the number in first, so 74. No, 41 times. 74 sine divided by 77 equals shift sign. You would have to do that. It was the same. That's what we had to use. You would have to do some sign. So you always put the number in first. That is. All right, how many people got C, C done? Okay, let's see what we got. So you should get this. Whoops. Y equals 155 sine 13 over sine 67. Is that good so far? Right, move that over. Not looking for an angle. It already has sine of 13 and sine of 67, so I can just put it straight into my calculator like that. So I go 155 sine 13 divided by sine 67 equals 37.87, so 37.9. Do people get 37.9? Yes? Awesome. No units because this is just calculator practice. D. How many people got D done as well? Okay, good. Most people. Okay, so theta's on the right. That's a little weird maybe, but that's okay. It doesn't matter. So I take the 20 and multiply. And I'm looking for an angle, so this is the kind where we do shift sign. So I'm going to go shift sign bracket 20 sine 40 divided by 50, then close the bracket at the very end, and I got theta equals 14.8, so 15 degrees. Is that right? People get 15 degrees? Awesome. Any questions? If you're still having a problem with your calculator, you got to ask me at some point so we can take care of it.
So most of these questions, the variable you're supposed to solve is like on the top.
But you're going to set it up that way. But yes. That's up to you. So we'll do a practice question right now, and we're going to try to set it up just to have the variable on top. It just means one less step. Yeah, when you have to solve. And it shows understanding. It shows you're planning ahead. You know what you're looking for. You understand the whole process. Okay, so draw that triangle. Instructions just say solve for the indicated length or angle. Round side lengths and one decimal place and angle to the nearest degree. So remember, this is not a right triangle, so we can't use SOHCAHTOA. It is possible to use sine law in right triangles. In some cases, that will work. But it's a bad practice. Sine law is a little bit more work. It's a little bit harder. There is more ways of making a mistake. And typically speaking, part of the understanding is that you know that we use SOHCAHTOA for right triangles. It's simpler. It's just the way that we do it. So on a test, when you have both, you're showing me knowledge and understanding that you're using SOHCAHTOA at the right time and sine law, cosine law at the right time, right? So keep that in mind. But this is not a right triangle, at least not as far as we know. So we can't use SOHCAHTOA. So remember what I told you at the very beginning, that the key is knowing which side lengths and angles are across from each other. I'm given 3 pieces of information. I'm asked to find x, which is across from one of the angles. And I've got a side length and angle across from each other. So sine law, and there's a couple of kinds of questions that are a little bit trickier. We'll see one later. This isn't one of them. This one's straightforward. What am I finding? Am I finding a side length or an angle? Side length. So I'm going to use this. If you didn't, then you use the other version, your unknown's on the bottom, and you need an extra step to put it back up on top. So once you get this stuff, and if you can remember to think about it, pick the right version so you get x on top. Right? It's that easy. And then I start subbing in. So I'm going to start with x so that my x is on the left, because why not? And across from the x is 36, so sine 36. Again, I'm always thinking about these little things as I'm doing this. I'm thinking about how it's always sine of an angle, or cosine of an angle, or tangent of an angle, right? And so 36 is an angle, so sine of 36 makes sense. Equals b, which is 81 over sine of, again, an angle, 61. You can't do sine of 81. That's a side length that makes no sense. Watch for, this is going to help us for an example later, so just take a look at something. Look at how I put n in for A, and I put L in for B. Like, the letters in the question are not the same as the letters in the formula, right? There's no connection there. Why did I choose to put N in for A? Because it was across from X, and I've got X, right? That's little n, that's big N, they have to be together. Does that make sense? That's why I put big N there. It's got nothing to do with that variable A. has to do with the relationship between 36 and x. That's why I put them together.
Would it make any difference if you switch to x in the very states with what you want in the
If I wrote them left and right instead of right and left kind of thing,
Yeah.
wouldn't make a difference. It would just look like that question up above where your unknown's on the right side. Which for us at this point, that's not harder. But some people like the consistency of sort of always having x on the left, you know what I mean? So it's up to you. Wouldn't make a difference in the answer for sure. Okay, go ahead and solve. So x equals 81 sine 36 over sine 61. Plug that into your calculator. Who's got an answer for that? Tara? 54.4 centimeters. Anybody else get that? Wonderful. Question?
If we're like just giving like questions on tests, can we just skip to the answer? Or
No.
we have to write the
You have to write every one of those 4 steps would be required.
rearranging?
Yep.
Because we may not need to insert or substitute.
Typically, the question's going to look exactly like that. It'll be 4 steps. Formula, substitute, rearrange, solve. Okay, try the next one. Write it down. So what was that first thing that I keep doing every time I get a question like this? Remember, I'm going like this. You could do all 3 if you want. The green line, there's nothing on either side of it, so it's not necessary, but if you want to, you could draw all 3. Sometimes there might be cases where that's helpful. So what's going on in this question? What are we solving for? Jaden? An angle. So which version of the formula do we want to use? Nice. So sine A over A equals sine B over B. Remember, I said this before. Notice how we're not using the sine C over C. Like, there's no reason. We just pick the first 2. We just always kind of start with these. Okay. So we're going to sub in sine theta. Who could tell me what's going to go below sine theta? Alan? Yep. And then who wants to continue and do the other side? Go for it, Jim.
Sine 75 over 17.
Good. And again, look at how those are across from each other, right? So we picked those 2, and these are across from each other, so we picked those 2 to go together. Nice. Okay, go ahead, rearrange, solve. This is the harder kind. Get back in the habit. It's been long 2 weeks. Get back in the habit of reflecting as you're working. So, are you setting it up correctly? Did you pick the right formula? Did you sub in properly? Did you rearrange properly? And then compare this question B to question A, did you have a hard time putting one of them into the calculator but the other one worked? So maybe this one you got the right answer, but then when you do this one on your calculator, you get an error. And the reflection there is, I can do one type for the side lengths, but I can't do the type for the angles. And you think about that, go, okay, how am I going to resolve this? Like, who am I going to ask? How am I going to get help? There's one easy way to get some help for that, right? But think about how you're going to solve that. So who's got an answer for this question? Riley. 58 degrees. Nice. That's what I got. 58.46134 and so on and so on and so on. Other people got 58? Yeah. Very good. Any questions? Okay, I'll take a look at it while everybody's copying this down. Yep.
For the question that you have to write down, like you didn't write down this one.
I think I answered it all correctly and then.
It looks like you forgot the shift sign.
Oh, yeah, the shift is.
So when you get this, you could just go shift sign 90 degrees.
So yeah, we're looking for, the angle, you use the shift sign.
That's right. Which one is this? Oh. Shift sign. Now, see how this opens a bracket for you? You have to close that bracket. That's what's assigned. You see that? Divided by. Oh, you close the bracket here too. You're not supposed to do it. Yeah, first one is this. Divided by. Okay, something a little bit different about this one. What happens when I do this? Let's see. What do we start with? We'll start here, and then we'll go here, and then we'll go here. What's different? See how that visual of drawing the line helps. As silly as it might seem, I didn't do the green one over here. What's different here? Red and red both have something. Blue and blue both something at both ends of blue. Green has nothing, right? It's got a variable, but variable, but that's it. Same thing here. The green one has nothing. What's different about C? Riley? Yeah, I've got nothing across from theta. So don't write this down. Here's the mistake that people would do. They'd go sine theta over 21 equals sine 40 over 18. Why is that wrong?
21's not across.
Those are not across from each other. So that's not how the sine law works. So this whole thing is wrong. We are looking, so what do I do? What can I do? Can I? Equal sine C over C. That's actually a good idea. That would help. And if you got stuck, that would be a good way to do it. What else do you notice? Not a right triangle, so we can't use SOHCAHTOA. Unfortunately. Jaden? You sure? Yeah. How am I going to do that? Okay, so use sine law to find C. And how's that going to help me? Okay, I see some other hands. That's good. Let's try it. And let's see if other people can figure it out too. So let's use what we have to find what we can, in other words. All we can find is angle C, so let's do it. Now, so let's write it down. So we're going to solve for an angle. So we're going to do this. One other thing I want to point out. So write that down, then put your pencil down and just watch, but I really need your attention. This can be very confusing. We talked about this a little bit, and I prepped you for it earlier. This A is not the same as that A. We use the same A in the formula no matter what we had. We had an M here and an N here, and I used A, right? Here there was nothing. They don't even have variables. And I just used A because that's a formula. Like Pythagorean theorem, we tend to always use A squared plus B squared equals C squared, right? ABC. In this case, the triangle happens to be labeled ABC, but that's not the same as the formula ABC. Now you can, in some cases, put A in for A and B in for B. And if you wrote out all three, C in for C, like you could do that. But I think it's important to know and to understand that this is not the same A as that. What's important is that when I sub in, so for example, I'm actually going to do this, sine of C over 21. I subbed C in for A. Why? Because that's what I'm trying to find. And across from it is 21, so I need to use that. And then it turns out I am actually going to use B for B, but that's just a fluke. You might do that or you might not. So sine 40 over 18. Does that make sense? If that's confusing, don't worry too much about it. It doesn't come up a lot, but it does once in a while, and we'll see it another time here or there. But it's a good thing to realize. We use the same formula with A's and B's no matter what the triangle looks like. The triangle could be X, Y, Z, D, E, F. This one happens to be ABC. Doesn't mean it's the same ABC. Okay, sub in, or we already subbed in, so now rearrange and solve. I got 48.5, so 49 degrees. Does that look right to everybody? Nice. But that's not what we were supposed to find, so what do I do now? We're complete. Very good. So theta is 180 minus 40 minus 49. And that gives me 91 degrees. There's two different kinds of questions that can have a bit of a trick where it doesn't give you the information to solve for the angle or a side length directly. You have to do something first, and you'll only catch it if you're thinking about things that are across from each other, right? If you're not thinking about that, like I showed you before, you're just going to sub in whatever you're given, but it's not going to be right. Any questions about any of that? Okay, so you can write down, there's our practice, it's on the classroom, 366, 1, 2, 3, ACE, and number 6. And I'm not going to have you copy down. I'm going to do one more thing before I let you get started on the practice. It's just going to be quick. I just want you to watch, but I do want you to pay attention. It's really neat, simple little proof that we're going to do. As long as there's no questions. But I do want you to pay attention. This will be on the classroom. So if you want to write it down or look at it again later. The SOHCAHTOA ratios are very complicated, and we asked, like I remember Ziggy, we had a few conversations about like what exactly are they? Like where do they come from? What are they? It's really hard to explain. You need a totally new, different kind of high-level math, like university-level math, to really do the work required to see where SOHCAHTOA comes from. But if you think about similar triangles, you can understand what they're talking about to some extent. That's about as good as we can get in grade 10. But once we have SOHCAHTOA, if we ask, where does sine law come from? Why is it A over sine A equals B over sine B equals C over sine C? Well, let's take a look. So we're going to do two things. Step 1, and I'm going to start with A. So remember, sine theta This is right triangle trig. So katoa, sine theta is opposite over hypotenuse. Remember that from December? It was a long time ago. Remember that, okay? And so sine of A, what's opposite from A? H. What's the hypotenuse in this triangle over here? It's B, right? Little b. Are we okay with that? And I'm just going to rearrange this, bring the b over to solve for h, okay? Don't ask why, you'll understand in a minute. Step 2, I'm going to do the same thing. Sine theta, opposite over hypotenuse. Sine b is opposite, which again is h. And what's the hypotenuse of b? It's little a. And I'm going to solve this, bring the a over, equals h. Okay, so I've got these two little mini formulas that no numbers, I just rearrange them. Everybody happy with that? Okay with that? Sidebar, think about this. If x equals y and y equals z, what can I conclude? Good. Does that make sense? If two different things equal the same thing, they have to also be the same. If I'm the same height as you and you're the same height as him, then we have to be the same height. Doesn't that make sense? Both of these things equal h. Therefore, they must equal each other. Excuse me. So b sine a equals a sine b. I divide by b and divide by a to move those things around. Sine a over a equals sine b over b. And you could do the same thing with c and recognize that it's just true for all of them. So there's sine law. It's just a simple rearrangement of SOHCAHTOA. When I take a non-right triangle and turn it into two right triangles, do a tiny little bit of algebra, that is something that you could recreate, right? This is a proof or a derivation of a formula that you could easily do in grade 10. Pretty cool. Okay, there you go. You can get to it.